Yeah, so it's 6 o'clock. We'll wait for a couple of minutes and then we'll start. Okay, so we'll start. I think somebody's mic is on. Let me just mute it. Okay. I mean, if you have any questions, you can unmute, but other than that, it's just adding the background noise. So that's why I've muted some participants. So let's get started. So basically, this is the first class of this course for TA-ship. So we'll discuss uh, some topics related to first week course content that was covered. And the way I do it is I usually discuss sometimes whatever was the discussed in this corresponding week. But since one like this first week was only basically introduction and all those things, so there was not like major concept or anything there. So what we'll do is we'll try to solve some problems today uh, because main content of the course is beginning from the second week. Okay, so nonetheless, these basic concepts are also important because, as the name suggests, it's a mathematics course, and like underlying it's a mathematics course. Application is in the finance concepts, but it is essentially a mathematics course, right? So before we go into the detailed discussions about financial mathematics concepts, it is a good idea to just start with some basic maths concept. So some of them were discussed in the class, and some uh, sample problems were also discussed by professor. So we'll build upon on those things. So uh, there was a discussion on see, because the thing is I will not discuss that first week's assignment questions because I think the deadline is still there. So if somebody has not yet done that, I mean I should not do it. So we'll mostly not going will not go to uh, those questions. Let me just check what is the deadline for assignment one. Yeah, deadline is next week, 5th of February. So yeah, I cannot discuss those questions, but we'll discuss more or less similar type of questions because the concepts are same. So first one was regarding the percentages. Okay, so we'll take some problems because basically everybody knows about the percentage because since childhood everybody's grades at least till 11th 12th comes in terms of percentage. So as a concept it is very well known, I hope. So basically whatever is the quantum of your substance or things, you make it as a proportion or a fraction of 100, so that is called as percentage. So let's take some problems, then only we'll understand something, or uh, it will be more clearer because everybody thinks percentage is a pretty simple concept. I mean, it can be, but many times you can trick people also. So that is also there. Before starting, can anybody just confirm if the audio and screen etc. is fine? Because I can see the screen, but I'm not sure about audio. It's on only, so it should be fine only. Let me just check once again because it has happened one time that I recorded the video without audio, so I don't want to repeat that mistake. Okay, so uh, yeah, regarding the percentages, so let me just see if I have. I mean, I have a lot of previous year various exams questions I have. So we'll take some of them. Okay. So the question is, if, or not if, A is X% more than B, and is X% of sum of A and B. Okay. Then what is the value of X? This is the question. And you have four options: 50%, 62%, 75%, 37%. Okay. So this is a very innocent looking question, and trust me, many people do this wrong. Okay. So uh, I mean, what should we do? If I wait for you to solve it, it will take a lot of time and we'll not be able to cover other types of problems, because see, majorly the basic concepts for this course include percentages, then progressions, arithmetic, geometric, recursive, etc. Then that growth and decay rate kind of things. Then combination, permutation, and towards the end that random variables, expectation, variance, standard deviation, all those things are there. So we have a lot of things to cover, because I think from next class there will be more things oriented toward financial mathematics. Even mathematics will be there, but these basic concepts we should cover today only. So let's solve this one. Okay, so I mean, it is like in this question, everything is in the uh, sentence, or that structure, how it is framed. That is the main thing. If you understand that, then it should be fine. Okay. So first sentence is A is X% more than B. So for example, if A is or even let's say X, we can take as 50. Let's take one option. So A is 50% more than B. So that means A is 1.5 times of B. So that means this A is nothing but 1 plus X times B. So here we are taking X in fraction term, not in the percentage term. Okay. You can do that. You can write X by 100. So in that case, X will be in percentage. I'm writing it in fraction term because it is easier to solve. Otherwise, I have to write everywhere X by 100, X by 100. So that is, leave it. Okay. So that is first equation that we have. And let's say we number it 1. Then there is a second part to this sentence which says A is X% of sum of A and B. So that means A is X%. So since we are taking in terms of fractions, no need to write by 100 here. And it is equal to X% of sum of A and B. So sum of A and B is this. Okay. And now we need to find X. So here there are 3 unknowns, A, B, X, and 2 equations, equation 1 and 2. Okay, so this is equation 1. So how to find X is the question. So we can eliminate some things. So let's try to do that. We are interested in X, right? So let's take equation 1, and from equation 1, what you can write is 1 plus X is A by B, right? And we'll try to get this ratio A by B in equation 2. So that is first thing. And from 2, what I can write, I want A by B there, so I'll divide the whole equation by B. So this will become A by B plus 1, right? And then I'll substitute this value of A by B in this equation. So 2 places will substitute. What that does is that makes your whole equation in terms of x, and then you can solve it. Okay, so therefore what you get, 1 plus x is equal to x into 1 plus x, and that plus 1 remains as it is. So basically you have 1 plus x equal to, this is x plus 2, so multiply, so x square plus 2x you'll get, and then you can take all the things on one side. You get a quadratic equation of this nature. So now it's a quadratic equation, so it will have 2 values. So you should know that simple formula is there, right? So if you have a quadratic equation, let's say of this form, ax square plus bx plus equal to 0, you can get x as minus b plus minus b square minus 4ac by 2a. Okay, so we are going to use that. Here a is 1, b is 1, c is minus 1. So therefore your x will be minus 1 plus minus b square is 1 minus 4ac by 2a. So basically you have x as minus 1 plus minus root 5 by 2. Okay, so now the thing is, it will have 2 values. See, root 5 will be slightly greater than uh, 2, right? Because square of 2 is 4, so square root of 4 is 2. So root 5 is slightly higher than 2, that we know. So you have 2 values for x, which are minus 1 plus root 5 by 2, minus 1 minus root 5 by 2. Okay, so which value do you think will be feasible and which value is not acceptable? Can anybody tell me? You can type it out also, no need to chat or switch on your microphone if you are not in a quiet environment. Yeah, first one, right? Because this second one, it's a negative number, or not number, negative fraction, or I should just say negative value. So it is not possible because x is a percentage, and percentage is always greater than 0. Okay. So therefore your x is nothing but minus 1 plus minus root 5 by 2. Okay, so can anybody solve this and get the value of this fraction? As I said, root 5 is slightly greater than 2, so 2.1. You subtract 1, so it is 1.1. 1 second. Yeah. 1 second. Root 5. Let me just find also. Oh, it's not 2.1, it's 2.2. 2.24. So you subtract 1, it's 1.24 divided by 2. So 0.618. Okay. And since we are options are in percentage, you can multiply by 100. So that becomes 61.8%. So if you look at the options, so second option is the correct one. So option 2. So like this, there are very, in percentages topic, there are very innocent looking questions many a times. But if you make a mistake in understanding or reading the sentence, it will be very bad. I mean, you won't be able to solve the questions. So that's the trick, that you should always pay attention to the language of the question. Okay. So maybe we can take one or maybe one more question from percentage topic. So and we'll share these slides or notes. I will share at the end uh, with the PMRF, with the NPTEL team, and they usually give the link to the registered students for this course, and you can download these notes from there. Okay. So if somebody is writing, it's okay, but if you are in the interest of time, we should go to the next question. Okay. So let's take one more question from percentages. Okay. So yeah, I think we have uh, some new people, so no issues. Okay, so now this is also interesting question. So there is a class. Okay, uh, I'll just write the question so that you understand how they try to twist the language of the question. So in a class, 50%. Oh, sorry. If 50% of the boys were girls, then there would be 50% more girls than boys. What percentage of overall class are girls? So what is the percentage of girls in that class? Okay, so this is the question. Again, very innocent looking statements, but you need to uh, you know carefully look into this, because it's not that straightforward. So in these type of things, if you're getting confused or something, the best idea is always to get some help with the pictures or images or diagrams, whatever you want to call it. So let's say this is the class that they are talking about, and in that class, uh, there are two categories of, let's say, um, boys and girls. So we don't know the percentage of them. Okay. So let's call this as B and this as G. So total strength of class is B plus G. Okay, so boys and girls. Now the first statement says that in a class, if 50% of the boys were girls, so what is the 50% of boys? 50% of boys is nothing but 50 percentage of B, which is equivalent to 50 by 100 into B, or nothing but B by 2. Okay, so what they are saying is, if out of B by 2 boys were girls, then there would be 50% more girls than boys. So if this B by 2 uh, uh, boys are added to the girls side, then you know in this case total number of girls would be, G will be there and B by 2. So these are like 50 percentage of the boys that are shifted to girls side. Okay, and this total number of girls would be 50% more than the boys. Okay, so now that is the tricky part. I hope you understand the confusion here. Okay, so now total number of girls is this much, and total number of boys is just B by 2. Okay, And what they are saying is, from this condition given in the statement, uh, if you shift this half of the boys in the girls side, then there would be 50% more girls than the boys. So that means this g plus b by 2 is 50% more. That also means that it is 1.5 times of the boys that are remaining. Okay. So that means this g is nothing but 0.5 into b by 2. Okay. 1 second. One second, guys. Just switch on the fan. Mm, there is some mistake here. Let me just see the statement if I have written it correctly. Uh, mm, 1.5 times b by 2, correct? Yeah, so this basically means g is 0.25b. So that means whatever is the number of boys in a class, girls number will be 0.25 of that. Okay, but are they asking this? They are not asking this, right? So this is not your final answer, not the final answer. Okay, what they are asking is, you should pay attention. They are asking is what is the percentage of the girls in that class. So basically what that means is uh, they are asking g by b plus g is equal to what. Okay, and since we know that g is 0.25b, you can just substitute it here. So that basically means 0.25b b plus 0.25b. So bb gets cancelled from numerator and denominator, so you just have 0.25 by 1.25, and it is nothing but 1 by 5 or nothing but 0.2. Okay, so in percentage term it is 20%, and that's the answer. Okay, so this is your answer. So basically in that class, whatever number of boys are there, for example, if there are 100 boys, there are 25 girls, and total class strength will be 125 in that case. Okay, so like that, you have to tackle these kind of questions. I hope everybody is on board. Uh, the main key takeaway of these percentages problems is that you should always be careful while reading the questions, because they most likely will jumble those statements. Okay, so maybe I can give you one homework problem. If you are interested, you can solve it. uh,
Hello, sir. Sorry to interrupt.
yeah, tell me.
Uh, in the step where you have taken g plus b by 2 is equal to 1.5 into b by 2, there, how did you get that 1.5, sir?
It is coming from here. One second. Yeah. So see, this is the first part of your uh, uh, statement. So that is what is written here, g plus b by 2. And they are saying that then there would be 50% more boys, more girls than boys. So once your b by 2 boys shift to girls side, so total girls will be g plus b by 2, and the boys will be only b by 2, because half of them shifted to the girl side. And that means this number is 50% more than this number. So I can write it, maybe if you are getting confused, I can write it in a simpler way also. So that is nothing but 1 plus 0.5 into the number of boys that are left. Okay, and this 0.5,
Got Yes,
it comes from the this 50% condition.
got it,
Okay.
sir. Got it. Thank you, sir.
Yeah. So then I think percentages, maybe you can take one homework problem. If you're interested, you can solve it. So uh, mm, uh, one second. This class problem we did, right? So I was looking for some other problem. Mm, yeah, so maybe this is a different variety of problem. So a two-digit number is 60% of x, and the two-digit number formed by reversing the digits of original number is 60% more than x. Find x. This is your homework, because we have to see other types of problems also. Okay, so I'll give you the answer. Maybe you can verify. Mm, it's an interesting question actually, but let's not go there because it's already 6:40 around. So basically, here I'll just give you the basic framework. So basically, if it is a two-digit number, so you have to assume it is AB, and A and B are unknown digits. But since it's a two-digit number, it will be 10A plus B. Okay, so whatever is the units place, that is B. Whatever is the tens place, that is A. So that is 10A plus B. So that 10A plus B is 60% of x. So that is 10A plus B is equal to 0.6x. That is your first equation. And when you reverse, basically you make AB BA. So in that case, your number will be 10B plus A, and that is equal to 60% more than x. So that is 1.6 times of x. Okay. Okay. So we have these two equations, and I'll give you options also, because without options you may have more than uh, one x values. Okay, so options are there: 45, 54, 63, 72. Okay, so now correct answer is 45. Okay, so this is your answer. So try to figure it out. Okay, so let's go to the next one. So these are like percentages kind of things. Uh, then professor discussed about some series and some formula for them, such as arithmetic progression, geometric progression or geometric series, recursive series, etc. So we'll take some problems on those, and uh, then let's see about other things. So yeah, so I am assuming that you have gone through the class lectures and you know the formula for arithmetic progression, how to find the nth term of arithmetic progression, and similarly for summation of uh, n terms of arithmetic progression. If not, I'll just write those things here. Okay, so uh, we'll usually call it as APE and GPE, but let's revise it. So if you have arithmetic progression, so basically you'll have first term A, then you'll have second term which will be AD. Basically you add common difference, right? So that's how it goes. And so you call this as, let's say, first term, this is second term, like that. Okay, so in that case you can write the nth term as first term plus n minus 1 into d. Okay, and just to avoid confusion, I can write it as tn, because otherwise it may be confusing. So this is your nth term of your series, and sum up to nth term is nothing but n by 2 into first and last. So a plus uh, this tn, so last term. So if you know first and last term, you can just add those two and multiply by number of terms by 2. And then just if you put this tn formula, you get the another famous expression, which will be 2a plus n minus 1 into d. Okay, so this is about arithmetic progression formulas that you should be aware of. Here only we can discuss about geometric progression, and these things become useful for this course when you have uh, interest calculations. Okay, so simple interest, compounding interest, uh, essentially they can be looked into as AP, GP, etc. Okay, so you'll have first term, then common ratio, then basically you just multiply by that common ratio. That common ratio can be greater than 1, can be less than 1, anything is fine. But if it is an infinite GP series and if R is greater than 1, it is usually non-convergent series. So there you won't have any summation formula. We'll see. Okay, so for a finite GP, uh, your Tn nth term will be A into R n minus 1, right? And Sn will be, if I'm not wrong, A R power n minus 1 by 2, right? 1 second. Let me just check. I mean, this was discussed in the class also, so you should also know this. But let me just see the formula. Mm, 1 second.
Sir, is it 1 minus r to the power n?
And like this, right?
No, sir. Sn is equal to a into 1 minus r to the power n divided by 1 minus r.
Doesn't matter. I mean, I can multiply this ratio by minus 1 and it's the
Yes, sir.
same thing. Okay, so Then for an infinite geometric progression, this Tn formula remains same, but this is 1 minus r, and your mod of r, I think, should be less than 1, something like that. Basically, the idea is, if your r, which is called as common ratio, if it is greater than 1, the series won't converge. It is a divergent series, so you will not have a finite sum. So you will have only finite sum when it is a convergent series, and that is this condition is basically making sure that it's a convergent series. Okay, so those things are there. So then let's take some problems, because these things are already discussed. These formulas you already know. Okay. Mm, okay. 1 second. So uh, oh, this is a GP problem. 1 second. We'll take some AP problem and then maybe GP problem. Okay, so this is the problem. Sum of first 25 terms in an arithmetic progression is 525. Sum of next 25 terms is 725. What is the common difference? Okay, this is the question. So now, basically for AP as well as GP, if you can find two unknowns, which are the first term, and for AP it is common difference, for GP it is common ratio, then everything becomes clear. Then you can use all those problem formulas, etc. Okay. So now that is the challenge, right? How to find those A and D. Okay, so let's say we call the first term as A and common difference as D. So in that case, let's start with this problem. So first, let's use the first sentence. So they are saying the sum of first 25 terms is 525. Okay. So let's say sum of first 25 terms is 525. It is given. But the next part says sum of next 25 terms is 725. So that means you know, that means if you add sorry, not as, if you add 26th term, 27th term, so on and so forth, up to 50th term, that summation is 725. Okay. So let's call this as some number k, or some notation k. So what basically it means is, if you take this also implies that if you take, let's say, sum of first 50 terms in this series, that will be nothing but sum of first 25 terms plus k, right? That is how it will be, right? So what does that become? It is 525 plus 725. So that will be 1250. Why am I doing this way? Because we have the formula for sum of first n terms, right? So it can be 25 or 50. We don't have the formula for intermediate things, no? So now it is somewhat clearer, no? So what we can do now is, let's say we can use this one. So S25 is 525, right? So that means 525 will be 25 by 2, 2a, 25 minus 1 into d. So that essentially is 2a plus 24d. So if I take 2 common, this denominator 2 gets cancelled out. So this will just become a into 12 plus d. Okay, and then I can divide by 25 on the both sides, and it will become 21. So I get one equation which is a plus 12d is 21. Okay, so let's say this is first equation, and apply the same thing to your S50. S50 will be 50 by 2, 2a plus 50 minus 1 into d, and that is equal to 1250. Okay, so here unfortunately that 50 minus 1 term becomes 49, so you can't take 2 common from the inner bracket. Doesn't matter, you can just divide by 50 on both the sides. So if you do that, if you divide these two, so what do you get? You get 25, right? So then you multiply by 2, so you get 50. So the other equation that you have is 2a plus 49d is 50. So now you have two unknowns, two equations. You can solve them. We are interested in d, so I want to eliminate a. So I will take a from here. That will be 21 minus 12d, and I will put it here. So that becomes 2 into 21 minus 12d plus 49d equal to 50. So this is 42 minus 24d plus 49d is 50. So it is nothing but 8 will remain here, and here it will be 25, right? So 25d. So d is nothing but 8 by 25. So this is your answer. Then if anybody is interested, they can find a also. What is your first term? You can just do this way. So a will be 21 minus 12d, right? So since these are not proper fractions, I am not doing it. You can calculate this also, but not asked. In questions, they were asking only about d. Okay, so this was the trick in this question. If you can understand this part, you can solve this question pretty easily. But if you don't, then you will be stuck. Okay, so I hope you understood what we just did here. If you have any doubts, you can ask me. Otherwise, let's take one more problem. Yeah. So let's take one more interesting from EB. I'm not taking simpler problems because I hope that you can do those. These are slightly difficult ones, so we'll have some uh, different flavor of these things. There are many more problems like that, not only these, but since we have some limited time, I'm taking slightly different variety of problems. Okay, so we'll do one more about AP. Okay, so now let's take this one. So, oh, sorry. If 4 times the fourth term of AP is equal to 9 times the ninth term of AP, then what is 13 times the 13th term of this AP. Okay, so it looks like a simpler problem, but it's not that simple. Okay, so and maybe you can take it as a data entry type of question, so there are no options also. So you get these type of questions in your gate exam or something like that. So no need to worry. Again, you have to go statement by statement. So what will be the fourth term of your AP? It is, let's say, T4. It will be nothing but A plus 4 minus 1 into D. So basically A plus 3D. And ninth term, T9, will be A plus 8D. Okay. So what this question says is, given condition says that 4 times T4 is 9 times T9. That means 4 into A plus 3D is 9 into A plus 8D. So now you have to simplify. So what is this? This is 4A plus 12D equal to 9A plus 72D. Okay. So if you take all the terms on one side, 5A plus 60D is equal to 0. So you can further simplify. This becomes A plus 12D equal to 0. And what is this A plus 12D? Can anybody tell me? You can type it out also.
T13.
Yeah, so it's T13. Okay, so that is the main thing. If you don't look into this connection, there is it will be very difficult to solve this problem. Okay, but I think you found it. So A plus 12D is nothing but T13. Okay, so now it is 0 basically. So uh, you can. So what they are asking is, what is 13 times of 13 term? That will be 0. So this is one interesting question where you need to identify this step, because what usually students will do is they'll get A as minus 12D, and then what to do? Uh, it's a big question. Okay. Anyway, so this was one interesting one. So I hope you understood. Now let's take one GP one, because AP ones are typically easier, because you basically have two problems, two formula, and you just apply them and you solve the questions. Okay. So anyway, so let's take this question, GP now. Okay. So what this question says is, sum of first 12 terms GP, geometric progression, is equal to sum of first 14 terms in the same geometric progression. Then they have given additional information that sum of first 17 terms is 92. Find third term in this geometric progression. Okay, then there are multiple options, but let the options will not write them. Try to solve this because it's an interesting question again. Because usually when you expect GPs and all, I mean 99% of the problems that you encounter, they are usually whether they'll start from some A and it will either increase or decrease continuously. But this is a slightly different flavor of the GP. So you should understand that it is not necessary that GP has to always increase or decrease. I mean, it can be anything. I mean, not increase or decrease, I should say, not always positive or negative. It can be mixture of these two also. Okay, so let's use the first statement. What it says is sum of first 12 terms of GP is equal to sum of first 14 terms of GP. So what that means is S12 is equal to S14. Okay, and that's the counterintuitive thing, right? Either it should increase or decrease, right? But they are saying it is like this for this GP. And the trick here is you can write S14 as sum up to 12 and then 13th and 14th terms, right? That will, the total will make it as sum of total first 14 terms. Okay, and then S12 S12 get cancelled, and then what you get from here is T13 plus T14 is 0. So basically what it means is whatever is the sign of 13th term, the next term will be exactly opposite in size and exact same magnitude opposite sign. Okay, so that is fine. Now what? Another information that is given is about the sum of first 17 terms is 92. So basically S17 is 92. But now here we don't, I mean, two unknowns are there, right? First term and the common ratio. So you can't just use the S17 information, because what you are typically going to do is S17 is nothing but A into R power 16 minus 1 by R minus 1 equal to 92. So there are two unknowns, A and R. So you need to get some information out of this correlation. Okay, so yeah, what is the meaning of this now? So what will be T13? It will be A power A into R power basically it will be A into R power 12 plus A into R power 13, right? So you can take A into R power 12 common, so that will be 1 plus R equal to 0. And see, A cannot be 0, because if your first term is 0 of your GP, all the terms will be 0. So A cannot be 0. R can also not be 0, because then all the terms except the first term will be 0. So that means 1 plus R has to be equal to 0. That means your common ratio is minus 1. Okay, so this is the special case of your GP. So basically what it means is your GP that you are studying is of the form A. A will be, let's say, first term. Then you will have A into R. So next term will be minus A. Third term will be minus A into minus 1. So that will be A. and so on and so forth. So basically it's a GP where you only have A minus A plus minus plus minus. So it is oscillating series, and since it has a common ratio of -1, it is also GP. Okay, so uh, what they're asking you to find is third term of GP, right? So our objective here is to find third term of this GP. So that means this is your third term, right? So we need to find A. Okay, so now look at the last bit of information that was given, which is sum of first 17 terms is 92. See, if you add first two terms, it is 0. If you add third and fourth term, it is 0. So what it means is, uh, till S16, if you add A minus A, it is 0. Okay, and therefore your S17 is nothing but equal to A only, and that is 92. Because 17th term in your series is plus A, and that should be 92. So that means your uh, actual series will look 92 minus 92, 92 minus 92, so on and so forth. And this is your answer, third term. So answer is 92. Okay. So this was one GP which is oscillating between same values of 92 and minus 92. So you should be careful. If you don't infer these things, it is very difficult to solve these kind of questions just based on the formula. Okay, I hope you get the point. Okay, if you have any doubt, you can ask me. Otherwise, let's take one more GP problem and then we'll.
Sir, in
Yeah.
GP problems, we usually use S, right? Here, you have considered that therefore T13 plus T14 is equal to 0. Uh, what is that, sir? Like one step. I didn't understand.
See, they read the first statement of the problem. What they are saying is sum of first 12 terms, which is uh, you know S12, is equal to sum of 14 terms. So that is S14. So first statement, if you write in mathematical form, it is S12 equal to S14. But if you do the summation of first 14 terms, that means it is equal to first 12 terms and then sum of next two terms, right?
Yes, sir, got it.
So basically this S12 gets cancelled, and what it says is 13th and 14th term, if you add them, the summation will be 0, because then only sum of your first 12 terms and 14 terms will be same, right? So that was the trick here. If you get that point, then this getting common ratio of -1 is pretty straightforward. Uh, there could be another special case of such a GP also, where R can be equal to 1. Okay, I mean, it's a constant series basically. You'll have only one term A, but sometimes question setters try to confuse students also. So normal GPs you can solve. I am assuming that you're good enough to solve normal GP problems. These are some of the uh, lesser known problems that I am trying to take, so that you understand what we are doing here. Okay, so we'll take one more GP problem, and then we'll move on to the next part. Okay, we'll see what to do. Uh, okay. Mhm. Mm, okay. But this is actually very easy. So basically, there is one problem where you have infinite GP, they have given you the sum and first term also. So basically you need to find R. That one is easy, so let's not do that. Okay, what about this one? Mm. One second. Okay. Okay, so let's take this problem. It's a slightly difficult one, but we'll do it anyway. So, what they are saying is mth term in a GP is 3 by 4, okay, and nth term is 12. So basically, they have not mentioned whether it's a first term, second term, third, whatever it is. M and n are unknown, and they have mentioned that m is smaller than n. So basically, this mth term comes before nth term. That much they have given. If the common ratio r is an integer, then the smallest possible value for r plus n minus m is what? Okay, so I'm not giving you options. Consider it as a data entry. So basically, here you need to find r, n, and m, and then just do r plus n minus m. But the important thing that you should not miss here is this one. They're asking for the smallest possible value of this expression, r plus n minus m. Okay, so we'll see what it transpires into. So let's first write the mth term. Okay, so it will be 3 by 4. Okay, so it will be a into r power m minus 1, right? That is 3 by 4. Then you have nth term, which will be a r n minus 1, 12. Okay. Mm, okay. So now, what can you do here? Let's say if you divide these two expressions, so Tn by Tm, if you do, what you get, a gets cancelled, so this is r n minus 1, r m minus 1 is 12 by 3 by 4. So 12 by 3 by 4 is nothing but 16. Okay, and this ratio, if you use this thing, power wala thing, so it is n minus m minus 2 equal to 16, right? No, that minus 1 plus 1 gets cancelled, so this just becomes n minus m. Okay, so basically it is a division of two powers, so they get subtracted from each other when you remove the division. Okay, so now There is no other information in this question, so the only expression that you have is this one. Okay, so now what all possibilities are there? So 16, see, you need to write 16 as power of some integer, right? Because they have mentioned that r is an integer. Okay, so this one hint they have given that r is an integer. So how do you write 16? See, you can write 16 as 4 square, or even for that matter minus 4 square also is possible, because both are integers, plus minus is fine. You can write this as 2 to the power 4 or minus 2 to the power 4 also. Okay, anything other than these four combinations is not possible, right? You cannot write 16 as anything other than these four combinations. You can write 16 power 1 also, I mean, that is also there, 16 power 1 or minus 16 you can't write. So 16 power 1 is also possible. So there are 5 cases are there which are possible, right? So we need to find a case, I mean, we need to find smallest possible value for this expression. Okay, so let's look at this expression. It is r plus n minus m, right? So you need to find r plus n minus m. So if you carefully look, see, r is uh, the term in the bracket, and n minus m, if you compare the powers, maybe I should use same color for these two, so that you'll not get confused. Okay, so what I'm trying to say here is or maybe green one, let's say. So r is nothing but the term inside the bracket, and n minus m is nothing but the power of a possible uh, number, right? So let's go case by case. So let's take case 1, where you know this r power n minus m is 4 square. So what it means is r is 4, n minus m is 2. So r plus n minus m will be nothing but 6, right? So like that we can create one table. We want to find the smallest possible value for this, right? So let's create one table, so that every time we don't need to write all these things. So okay, r, one second, maybe I can make this one smaller. R n minus m and the final thing. Okay, so here you have r to the power n minus m equal to what? So first case that we studied, where it was equal to 4 square. So in that case, what are the values of r plus n minus m, right? So here r was 4, n minus m was 2, so this is 6. So let's take the second case, where it is minus 4 whole square. So here r is minus 4, n minus m is still 2. So if you sum it up, it is minus 2. Third case, let's take 2 power 4. So here r is 2, n minus m is 4, it is 6. Minus 2 power 4, r is minus 2, n minus m is 4, it is plus 2. And the last case, which is 16 power 1, here r is 16, this is 1, so the summation is 17. So now, can you tell me the smallest possible value? In which case do we get the smallest possible value? By looking at this table. Anybody? What I'm I'm asking is, in this table, in the last column, what is the smallest possible value that we get?
Oh,
So basically here, the smallest value
oh,
minus 2, right? The case 2.
yeah. Yes, sir.
Yeah, so that is your answer. So this question, it looks very small. There are not a lot of data given, but when you go to solve it, first you need to understand that you know, this is what they're expecting. They want you to check all the cases. There are 5 cases, and here they asked you the smallest value. There could be another question where they can ask you the largest value. So if they ask you the largest value, then the fifth case will be the answer, where you get largest value as 17. Okay, so anything they can ask. So this is how you tackle some of these geometric progression questions also. Okay, so this was about APGP. Mm, there is something called as harmonic progression also. Usually there are not many practical applications for it, so usually we don't study. But you can Google also what is harmonic progression. It is like inverse of your arithmetic progression. So, but maybe for this course it is not important. But since we are on this topic, you should look into it. Then there was something called as recursive series or recursive progression. Fibonacci series is the quite famous example of that. So basically, you add the two terms to get the next one, previous two terms to get the third one. But as far as problems are considered, not many are there. So we are not going there. Okay, so let's leave it at that. Then, yeah, then there was some discussion on this growth and this thing, right? Decay, etc., etc. So, mm, yeah, I mean, you must have seen some problems, right? That there is a bacteria which grows at some factor every day and find the number of days when its number becomes equal to 1 million or something like that. So that type of questions are there. Uh, okay, 1 second. Yeah, so maybe I will take one question of that type, because see, the standard template for growth rate and decay rate is nothing but uh, a into some number power x. So depending on that x, you can see whether it's growing or decaying kind of series. So those type of problems I'm not taking because this was already discussed in the class. So let's try to do something different. Okay. Actually, these are tougher questions. I don't want to do that.
sir.
Tell me.
Yeah, is this the level of difficulty for the questions which we'll be getting for the exam, or
Uh,
will it be difficult?
no, 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 no. These are in exams you will get way easier questions. Okay, so uh, I am taking tougher questions here. Uh, don't worry if you are. I mean, uh, like, do you feel these questions are tough or easy? That is the main question.
They are fine, sir.
So in exam you'll get easier than this. Uh, I mean, I'm just trying to take. I'm actually I have a question bank in front of me. I'm taking the toughest one from there. So in exams you can expect easier ones. Uh, okay, so don't worry. Mm, yeah. Okay. Mm, 1 second now. Okay, so yeah, maybe we can take one more question on that growth and decay. So one template problem I told you, which you can expect in your exams, etc. Also, where you have a bacteria or some sort of virus or something which grows at a certain rate per day, and they will give you some initial number, and they will ask you after uh, how many days it becomes 10 to the power 5 or 6 like that. Or another question could be, uh, they will not give you the initial number, they will give you the final number and how many days have been gone, and you need to find the initial number, starting point, etc. Those things are straightforward. You can Google them and you can get those answers. Let's take one slightly different flavor problem in that domain. Okay, so this is not strictly speaking ABGP kind of thing. It is a uh, that growth and decay rate wala things. Okay, so I'm not mentioning it separately because no need. Okay, so there is a lab. Okay, so on first day there are 100 uh, bacteria in a lab experiment. Okay, so that is your starting point, and after first day, uh, one out of okay, so one out of oh sorry, it's not like this. Uh, yeah, on nth day, where your n has to be greater than or equal to 2. Yeah, first day is basically n equal to 1 condition, but for the remainder of the days after first day, so second, third, fourth, and so on and so forth, uh, 1 out of every n particles produces another, oh, not particles, sorry, it is bacteria. 1 out of every n bacteria produces another bacteria if total number of bacteria uh, reaches to 1000 on day m, find m. So basically it is an integer m that you need to find. Okay, so initially you have 100 bacteria and finally you have 1000 bacteria, but in between there is something different happening. Okay, so this is the difference in this question as compared to the normal standard questions. So let's understand what is happening. So n equal to 1 first day, there were let's say bacteria, how many bacteria were there? So initially there were 100 bacteria. Okay, so this was your first day. Let's say you go to the next day, which is the second day, so n equal to 2. Okay, so what they are saying is out of every n bacteria, 1 out of every n bacteria produces another bacteria. So here n is 2. So what it means is 1 out of 2 bacteria produces another bacteria. So 1 out of 2 matlab there are 100, so 50 out of 100, this also means 50 out of 100, right? So initially there were 100, on the next day 50 produces another uh, uh, you know like I mean understand,
Total.
right? Yeah. Actually, I got started. Tell me.
Yes. 50 bacteria will produce another like 100, right?
No, 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 no. One out of two bacteria produces another bacteria.
Yeah.
So 50 will produce 50.
Yeah. Now the total will be 100.
No, no. See, what is happening here is, see, you had 100, right? So 50, 50, you do the division. These guys will produce another 50. So they will add 50 and these guys will not do anything. Okay.
Good.
So
Okay.
total will become 150 there. Okay. So on day 2, the total will be 150. Okay. So let's go to day 3. So here it becomes 1 out of 3 bacteria produces another bacteria. Okay, so on day 3 you had 150 at the start. So you have to divide it into 3 parts. So that will be 50, 50, 50.
Okay.
What they are saying is only 1 out of 3 are producing the replica of them. So basically, let's say this guy only produces 50 more. These guys do nothing because it is 1 out of 3, right? So therefore, the total on day at the end of day 3 will be this 50, 50. I mean, what I'm saying is these guys who are doing nothing, they are still there. They have not said that the bacteria are dying or anything. So that will be 100 plus these guys, 1 out of 3, right? So they produced 50 more. So that will add 50 plus 50. So that will be 100. So at the end of day 3, you have 200. Okay. So, uh, that is the difference in this problem, that not all of the bacteria are producing new bacteria. Okay. So as the number of days are increasing, less and less bacteria are producing new bacteria. Okay. The majority of population is not doing anything. I hope you understand. What I'm trying to say is, let's take n equal to 4. So on that day, you had 200 initially, right? This number. So 1 out of n, right? So now it will be 1 out of 4. So you have to divide it into 4 groups of 50, 50. So these 3 groups will do nothing. These guys will produce 50 more.
Only 50 will increase by the day increases.
Yeah, so that is the trick. Okay, so at the end of day 4, what you observe is your total is nothing but 250. So basically every day it is increasing by 50. So it is nothing but a arithmetic progression. See, usually in this type of problems you end up with a geometric progression. Okay, but this is a special problem where you end up with a arithmetic progression, and it is of the nature 100, 150, 200, so on and so forth, and finally you reach 1000. Okay, so now the question is, what is the I mean, you need to find m, which is, on mth day when you reach 1000, what was the number of day that has gone by. So uh, can you tell me what will be the m value? You need to use the AP formula, right? 1000 will be 100 plus m minus 1, and the d here is 50. So therefore it is 900 by 50. So 900 by 50, right? Yeah, so 90 by 5. Uh, 18, right? So m will be 19. So on 19th day, you will reach 1000 number of bacteria. Okay. So I hope you understood what is the difference in this problem. Okay, this is not a common problem.
So have a silly doubt. Uh, how do you like get to know if it's the answer is AP or GP? That thing.
You observe, right? See, n equal to 1 is 100, n equal to 2 is 150, n equal to 3 is 200, n equal to 4 is 250. And like if you do for n equal to 5, that will be nothing but dividing 250 into 5 parts, right? So that will be also 50, 50, 50, and one of them will add 50. So that will be again addition by 50. So basically, on every day, only 50 bacteria are getting added. So that's why it forms an AP. You can try for n equal to 5 also. I'm not doing it because we have limited time, but you can try also. N equal to 5 you take, so that means on fifth day, 1 out of 5 bacteria will produce new bacteria, right? So you need to divide 250 into 5 parts. So that will be nothing but 50, 50, 50, 50. So only 150 will do plus 50. Another 200 will remain as it is. So that will be 300. Understood? Is it clear? Or still a
Yes, sir.
doubt?
Yes, sir. Got it.
Okay. So, yeah. So this growth and these things, it's fine. We'll do that. I mean, this is enough for that. Uh, then we are almost at 7:35. So see, there is one important topic of permutation combinations. Okay, and then you have this statistical parts also, which is dealing with expectations, variances of different type of random variables. Expect, I mean, there are two types of random variables. One is called as discrete random variable. Another one is called as continuous random variable. Uh, I think we'll come across these expectations and variances later also in the course of this uh, in the due course. So maybe today we'll not go into those details, expectations, variances, because we don't have time. What we can do, maybe we can do some, uh, probability kind of problems, and then we'll stop for the day. See, in probability, I mean, like even in the technical part of a probability course, so you know, it can be divided into two parts, right? So in probability, uh, uh, how should I say it? First part is like those problems where you have set of cards, or coin toss, set of cards, or roll of dice, or maybe something like teams formation, etc. Coins, all those things are there. So basically, you'll have a typical set of problems. Basically, if you toss a coin 3 times, then what happens? What is the probability of getting 3 heads? All those things are there. In cards, you'll have 4 suits. Then, if you randomly pick a card from a deck of card, uh, what is the probability that it will be a king or a jack or a queen? All those things are there, right? In dice, if you roll a dice, what is the probability that the summation is odd or even? If you roll 2 dice together, 3 dice together, those kind of things are there, no? So that is one part of probability problems, and another part is dealing with these things. Uh, you know, uh, like, I mean, where you don't know these, what do you call, total number of cases. So basically, you use permutation and combination to get the total possible outcomes. See, probability is nothing but uh, a ratio of favorable outcomes for a particular event divided by the total number of possible outcomes in that experiment, right? So that is the definition of probability. So in many cases, to calculate the total possible outcomes, we take the help of permutation and combination concepts. Okay, so strictly, I mean, loosely speaking, probability topic can be divided into these two types. Okay. Uh, I mean, it's a very big topic actually. It's not easy to just summarize it in 5-10 minutes, but I hope you get the point. Okay? And the difference between permutation and combinations, I hope it is clear. So permutation is like taking a picture. So arrangement matters. For example, if you have a 10 fruits or 10 people, uh, yeah, I should not say fruits because they are identical objects, mostly considered as identical objects. Let's say you have different people, 10 group of 10 people. So then if you want to calculate the number of ways in which we can take different photographs of this group of 10 people, that comes under the permutation kind of thing. So basically taking a photo of group of uh, 10 people. So these are 10 people, they are not identical people, right? So total possible cases will be 10 factorial, all those kind of things, right? But if they are identical people, then only there is only one possible case, right? So you know choosing or okay, so what I'll do, I'll maybe take one problem so that you understand what I'm trying to say. But I mean, I'm not sure how much we can go into deep for this. For us, the third part is important. Okay, so there is something called as probability and statistics, right? So this statistics part is more important for us, which basically talks about distributions. Normal distribution is or Gaussian distribution is very famous one, and their properties. So properties include expectation, which is also called as mean, or variance, or standard deviation, or skewness. So this part is, I would say, more important for this course rather than the probability part. But since professor talked about it, I thought I'll just briefly touch upon it, and you know maybe uh, mm, yeah. So let's take one problem just for the sake of completeness. So mm, one second. And this probability, then there are advanced concepts like Bayes theorem, conditional probability, all those things are there. If required, we will study them later on, but today we don't have time also. So let's take this sample problem where you have mm, yeah, in how many ways uh, the word or the alphabets in the word demand can be rearranged to get a 6 letter word. Okay, so it does not mean that it has to be a meaningful word. So what basically they are trying to ask is demand is a word with 6 alphabets. How many combinations of uh, 6 alphabet words can we make by taking these 6 alphabets? Okay. So as I mentioned here, usually it is 10 factorial or whatever. Here it is 6 factorial. But the difference here is there is a repetition. So if you see, there is this alphabet D, which is repeated 2 times. So therefore, you need to divide by 2 factorial. So it is like, if you have a set of 6 things, out of those 6 things, 2 things are identical. So even if you take the photograph of those 2 things together and then swapping that position, it will be the same photograph, right? So therefore, you have to divide by 2 factorial. So I hope you know how to calculate factorial. It is nothing but like this. Okay, and 2 factorial is nothing but 2 into 1, so that goes away. So it is nothing but 13 to 12, so 360 ways. Okay, it's not 720. If you just do 6 factorial, that is wrong because there is a repetition of D. Similar thing can be asked similarly for a word, let's say attitude. So here there is not only one word that is being, or not only one alphabet that is being repeated. See, T is repeated. No, here it is only one. So it is repeated 3 times, right? So it will be, how many are there? 8. So 8 factorial by 3 factorial. That will be total number of possible combinations of 8 alphabet words that can be conjured out of this. But there can be different other combinations also where you have multiple repetitions. For example, mm, what can I say? Where I want two repeated words. Yeah. So for example, like if you have a word like bamboo. So here you notice B is repeated 2 times, as well as this O is also repeated 2 times. Okay, so in this case, your total possible combinations of this 6-letter word will be 2 factorial by 2 factorial, because there are 2 repetitions 2 times. If someone is repeated 3 times, that is 3 factorial. Like that, you have to do things. Okay, so I mean, we are running out of time. That's why I'm not taking uh, dedicated problems on this. But I think you understand what I'm trying to say. Because for this course, this is important stuff. Uh, the statistical part. The pure probability problems are not that into that.
Sir,
Yeah.
what are the things about studying under probability of statistics?
Um, See, as I told you, broadly it is about this thing. What you say? Uh, I mean, you're asking for this course, or in general
Yeah,
you're asking?
no, for this course.
Oh, see, uh, mm, I mean, uh, the details are yet to be taught, but broadly speaking, for any financial mathematics or any financial course, when you try to estimate risk or something, or some favorable outcome or something, you usually talk in terms of statistical models, and these models are basically based on certain assumptions of certain underlying distributions. Mostly it is Gaussian, but in some peculiar cases you assume skewed models also. So yeah, for this course, if you ask me from probability and statistics, first is distributions and their properties like expectations, variance, etc. And second thing could be this part of correlations, covariance. So basically, this happens in this if you study stocks, etc. So the stock price is one variable, and your, let's say, GDP growth is another variable. So how do these two variables are correlated? So that is called as correlation between two variables. So that is nothing but you take the GDP data, you take the stock price data historically, and then you try to find the covariance of these two distributions. Basically, you find the variance of two, and there is a relation for covariance, etc. Uh, so basically, these are the important areas where your probability and statistics come into picture. So
Yes,
other than
yes,
uh,
sir, got it, sir.
yeah, I mean, other than that, there could be another cases also. Okay, for example, option pricing, etc., or uh, this uh, bond values, how their values vary. But moti speaking, at this point, this probability and statistics, mostly statistical part is important. And nowadays, this ML is going into everything, right? So that also basically uses statistics only. It is just the assumptions that, see, basically what ML does is it you train it on certain data set, right? So it learns the distribution, probability distribution for that data set, and when you give it a new data set, it tries to predict based on whatever it has learned. So there also statistics is there. Okay. So I mean, yeah, this is the broad aspect of it. If you are more interested, there are two reference books in this main course page. One is by Kapinski and Zastan Niak. Uh, and yeah, that first book, Mathematics for Finance, I think its PDF is available only freely. You can just go and look at the index or the contents. You'll get a better idea what is to be coming. Okay.
Yes, sir.
Yeah.
Thank you, sir.
So yeah. See, we are at 7:50. I forgot there was one more topic, logarithm logs, natural log, log base 10, etc. So we'll take one problem and then we'll stop for the day. Okay.
Sir, when are we gonna have the next meeting, sir?
Pardon?
When are we gonna have the next meeting?
Sorry, I'm not able to hear properly. What are
Uh,
you saying?
when are we gonna have the next meeting, sir?
Next meeting, huh?
Yes, sir.
For this TA class, you're asking?
Yes, sir. Yes, sir.
See, usually it will happen on Tuesdays, but next Tuesday I am out of station. So maybe I'll postpone it to next Wednesday. But after that, every Tuesday uh, for next weeks. Okay. Except for the next one, for subsequent ones, it is always at Tuesday evening, 6 to 8. Next
Yes, sir.
Wednesday, 5th, it will be same time, but not Tuesday, Wednesday because of my some other commitment. Okay.
Okay, sir.
Okay. So we'll take one final question on logs because I forgot about it, and then we'll stop. Because see, this log is also very interesting thing. They can uh, you know catch you with different questions here also. So let's take one and then we'll stop. Okay. Mm, um, one second. Log. Okay. Let's solve this one only because we don't have much time. Yeah. So mm, uh, there is this problem. Okay. So it is log base 3 x plus log base x 3 equal to 17 by 4. Find x. Okay. So I mean there is one important property here of logarithms that you should know is you know uh, swapping the bases. So basically what I mean is uh, let's say this first term log 3 of x is some, let's say, t. Okay. Then I can write 1 by t, which will be nothing but 1 by log base 3x, and you can reverse these things. It will be nothing but log x3. Okay, this is nothing but the property of log. Okay, so that is the main crux of this question. If you understand, then you should be able to solve it, because see, you have to do substitution, right? So we have assumed that log 3 uh, log base 3x is t, and the second term becomes 1 by t then. So then you have this equation, you need to solve for t. uh, you know uh, so here it becomes t square plus 1 is equal to divided by t equal to 17 by 4. Then you just do the cross multiplication. You have 4t square minus 17t plus 4 equal to 0. Okay. And then you need to find t, which will be 17 plus minus b square, right? So it will be 289 minus 4ac, so 64 divided by 2a, so that will be 8. This will be 225, so that is 15. So your t will be 17 plus 15 by 8, or 17 minus 15 by 8. Okay. So this is nothing but 2 by 8, nothing but 1 by 4. And here it will be 32 by 8, so 4. Okay, but this is our substitution. So therefore log 3x is 4, or log 3x is 1 by 4. Both are possible. Okay. Log will uh, I mean, both cases are possible. You cannot neglect one over the other here. Okay. So here you need to use the property of log again. So that means x will be 3 power 4, and here x will be 3 power 1 by 4. Okay. So I'm not calculating the exact values, but both of these are acceptable values. There is nothing like it is not acceptable. One is not acceptable, and another is not. Okay. So these kind of questions are there. So I would request you to do basic revision of log properties. And with that, we'll stop. And yeah, as I said, the next time we'll meet on mostly Wednesday, because the normal timing for meeting is on Tuesday, 6 to 8 p.m. But next Tuesday, I'm out of station. So we'll meet on Wednesday, 6 to 8 p.m. Okay. So if
Yes,
you
sir.
have any, you can ask me. Otherwise, we'll stop for the day. And maybe from next class, it will be more towards financial mathematics course. This was introductory class, so uh, you might have felt that we are discussing which is not related to financial mathematics, but see, it's maths anyway, so these things will help you in a way, or in a way or other. Okay, so with that, we'll stop. Thank you for your attendance, and hopefully see you next time. And yeah, bye, good night, take care. Okay, I'll
Thank you,
close
sir.
the yeah, I'll close the class in a couple of minutes. I'll just share the notes, then I'll close it. Mm.